Hi everyone. In these next few slides I'm just going to go through several more examples that relate to the content in Chapter 13 just to make sure you're all ready to go for the upcoming exam. As always, I would encourage you to print off the slides, try to answer the questions on your own, and then come back here to check your answers against what I will be showing. So first of all, I just wanted to remind you about what a z-score is, what the formula is. So remember, if we want to convert a value to z, we take the observed value, or x, minus the mean of the distribution, which would be symbolized by mu, and then divided by sigma, which again would be the standard deviation of that distribution. And we know that if we have an observed value that's less than the mean, the z-score is going to be negative. If we have an observed value greater than the mean, the z-score will be positive. And then finally, if we have an observed value that's exactly equal to the mean, then we would expect that our z value would be 0, or our z-score would be 0. And again, a z-score is telling you something about the number of standard deviations your value falls from the mean. So if the z-score is positive, we know that our value, so as an example, let's say the z-score is positive 1.5. That means the value in question is 1.5 standard deviations above the mean. If the z-score was negative 2.1, then we know the value would be 2.1 standard deviations below the mean. So a z-score is telling us in standard deviation units how far away the value falls from the mean. It's important to understand what standardizing means. So if we ask you to standardize something in this course, we mean that we want you to convert that value to a z value. And if you took every single value in a normal distribution and standardized all those values, you would have then what's called a standard normal distribution. So it's a normal distribution, but you're presenting all the numbers not in their original units, but in z-score units. And when you do that, suddenly you come up with this distribution where the mean is equal to 0 and the standard deviation is equal to 1. And this is just a quick visual to show you what this would look like. So down here, you'll see we have this distribution where the mean is 10, 10. And obviously, we're not given the standard deviation, but we could figure it out as 20. So we know if we add 20, we'd get 1030. If we subtract 20, we get 990, and we could keep adding 20 and subtracting 20 this way. Now if we took everything in this first green distribution here and standardized everything, we'd get what we see over here in the blue distribution. So the mean suddenly becomes 0, and then our standard deviation is 1. And if you're wondering why the mean becomes 0, again, just convert 1010 to a z-score and you'll see. So 1010 minus 1010 all over 20. That's going to be 0. So the numerator becomes 0, and hence the whole thing would be 0. So again, just having this understanding of what standardizing means, of what standard units are. So we might say standard score, we might say z-score. Those mean the same things in this course. Let's now practice. I wanted to give you some practice with an example that hopefully will be familiar to you. We looked at this when we were talking about, way back when we talked about Chapter 11. So you might remember this distribution of the calorie contents of meals at Chipotle. So we saw that when we looked at the histogram that was in the original news article, we saw that it was, close to being normal. It's clearly there is some skewness here. But let's imagine that we've collected a lot more data, and we see that we do get a distribution that is normal. We get a distribution that's normal, and let's say that the mean of the distribution ends up being 1070, and the standard deviation ends up being 300. So I would write those numbers down. So mu is 1070, sigma is 300. So we're going to use those values for several upcoming problems here. So again, we might give you a scenario like this. We tell you about a distribution, we tell you it's normal, we tell you the mean and standard deviation. I would always begin by drawing that distribution, marking where the mean is, drawing it out, 2 or 3 standard deviations on either side of the mean, and hopefully that'll help you answer any problems that are thrown your way. So between what values do 68% of the meals fall? So here I've drawn my distribution. I've gone out 3 standard deviations on either side of the mean. And hopefully you're seeing that number 68% and it's reminding you of the empirical rule. It's making you think about applying that empirical rule. So again, we sometimes call that rule the 68, 95, 99.7% rule. 68% we know would be 1 standard deviation away from the mean. So if we go out in 1 standard deviation in either direction, we have 68% of our data. So between what 2 values? Well, between 770 and 1370. So again, knowing when you would apply the empirical rule and when you would not be able to apply it is going to be important. Above what value do 2.5% of the meals fall? So this is getting a little bit more challenging. Again, we have our same distribution here. Well, we know again that 68% of the values are within 1 standard deviation. That's one thing the empirical rule tells us. The empirical rule tells us if we go out 2 standard deviations, we have 95% of our data. And so if you're out 2 standard deviations and you have that middle 95%, we know we have 5% left over. Half of that 5% would be over here, or 2.5%, and the other half would be over here. So above what value do 2.5% of the meals fall? Well, that would be above 1670. So essentially we're asking what value cuts off the top 2.5% in this distribution. So that would be 1670. Approximately what percentage of meals have 770 calories or less? Again, we could apply the empirical rule. So if we had drawn out the distribution and drawn things out 1, 2, and 3 standard deviations away from the mean, we would see that 770 is exactly 1 standard deviation below the mean. And again, I know that 68% of my data is here. I know that if 68% is in the middle and the entire curve is 100%, then 100 minus 68% gives me 32%. If I divide 32% in half, then half of that would go over here, 16%, another half would go over here. So the answer to this question would be 16%. What if I'd phrased the question a little differently? Approximately what percentage of meals have 770 calories or more? So definitely pay attention to whether we're asking you for less or more, because that's going to have a bearing on what your answer is going to be, where you're going to be looking in the distribution, how you're going to be using Table B if in the event you cannot easily apply the empirical rule. So if 16% is 770 or less, then 100% minus 16% would give me the answer to this question, which would be 84%. Now, so far we've been able to easily apply the empirical rule, but there are going to be times when we cannot easily do that. Here's the perfect example. What percentage of meals have 825 calories or less? So again, I've drawn my distribution. Where's 825? Well, that's over here somewhere. Darn, I can't apply the empirical rule. This is not falling exactly 1, 2, or 3 standard deviations away from the mean. I might be able to approximate things based on where this is falling, but we want you to come up with as precise of an answer as you can. So in the event that your value does not fall exactly 1, 2, or 3 standard deviations away from the mean, what you have to do is you have to take this value, convert it to a z-score, and then use Table B to find your answer. So I pretty much just said this, so I won't go into more detail there. That's pretty self-explanatory. But here again is Table B. So we want you to be very familiar with this. We will provide this for you on the exam. So you will get a copy of this on the exam. This is not something you have to memorize or put into your notes. But we do want you to feel very comfortable with using this table, because there are many times now and later on this semester where you will be asked to use this table. And we also want you to remember something that we talked about when we first started going through chapter 13. So there are two types of normal distribution problems that we will ask you to work through. There are the forward normal problems where you start with an observed value, you start with a value of x, and you have to find the percentage that is greater than or less than that value of x. So you start with x, you move forward, you have to go to table B to find your percentage and to find your final answer. With the backward normal problems, we start by giving you a percentile or a percentage. And we want you to work backward then to find the observed value. And there's a nice little formula that might be helpful to have in your notes somewhere, so we won't give you these formulas on the exam. But anytime you see formulas and you feel like you would like to be able to use them, we don't want you to memorize them, we want you to put them in your notes. These two formulas definitely will be useful to you on the upcoming exam. So this would be an example of a forward problem because we're beginning with the value of x. X equals 825. And remember, we told you already the values of of mu and sigma. So mu equals 1070. That was from our initial slide where we told you about the distribution. Sigma equals 300. So to answer this question now, we would need to, and again, I personally like to draw things because I like to know where I'm looking on the curve. It helps me in terms of knowing if my answer seems to make sense or not. So I know I'm looking for this area. It's clearly going to be less than 50%, but it's going to be greater than 16% because we know below here we have 16%. So that helps me know if I'm on the right track. So z equals 825 minus 1070 all over 300. As usual, please check my arithmetic. I sometimes make errors, sometimes on purpose to see if you're paying attention. Here I got negative 0.8. So that's my z value. That makes sense. It's less than the mean, so I would expect a negative value. Then to answer the question, I just go to table B. I find negative 0.8. Here we go. And my answer would be 21.19%. So we'll go back here. So the final answer is 21.19%. So keep in mind, if you had a question like this on an exam, remember that when you're finding a z value, you always round to one decimal place. And so I believe when I worked this out, and let me get a calculator and just to double check here. Okay, I checked with the calculator, and the original calculation, it was like negative 0.81666. Okay, so it kept going and going. And so what I do is I'm going to round to just one decimal place. And since this is 1, I'm going to round to negative 0.8. So you might be tempted to try to round up to negative 1. I would not do that. I would leave it at negative 0.8, and that'll be our z value. And then again, we go to table B, and here, this was our final answer because we want to know the percentage that is less than or lower than a particular value. Remember, table B gives us all of those percentages that are less than or lower than a particular value. It gives us percentiles, and percentiles mean the percentage below a certain value. Okay, I'm going to stop here, and then we're going to pick this up. We have a few more examples to get through. Hopefully we can get through that in one more quick video.